Hi there, this is Jacob Nash, Algebra Lessons. This is Unit 3, Lesson 13 on transformations of quadratics. So remember, there are 17 lessons in this unit, so we're getting close to the end, kind of. So what are transformations? This is a pretty easy thing, because you know transformations just means how much does it go, up, down, left, or right. Simple. But the easiest way to know a transformation is if it's in vertex form, so that's what we'll be using in this video. So let's say we had y equals, so remember basically the default thing for standard form is this, which we learned on the last lesson. And basically, here's what it is. If h is negative, then it goes, you might be thinking to the left, because usually left is negative, but really h is in terms of x, and if h was negative, then that would mean that x was positive, meaning that would go to the right. So negative, it's backwards for this, so remember that. Don't get confused. Negative h means to the right. Positive h means it goes to the left. Negative k, this is the usual thing, down. And then positive k, okay, looks like a 4, but I never draw 4s like that. I always do that. That means it goes up. What does a mean? Well, we already talked about this like briefly on lesson 11, but if it's if a is in between 0 and 1, then there's not an exact like term for this. I mean, there technically is. You would call it compressed and stretched, but you would pretty much call this a compression, but to me that doesn't really make sense, because you think compression squeezed together, and when it's like this, it's really, to me, it looks stretched out, so I just don't like to use those terms. So just know, if it's from 0 to 1, then it's wide apart. But if it's less than 0 and greater than 1, then it's going to be kind of like close together, like, oh, yeah, I'm not going to split apart as much. So that's what that means. So we can use that to graph. So let's have an example. So let's say we had this. So first thing, how much is it going to go to the left? I mean, is it going to go to the left or right? Since it's negative, it's going to go to the right. How much? 3. So 1, 2, 3, right here. We at least know that's not a point that lands on it. It might not be a point that lands on it. Well, actually, never mind. What am I thinking? That's the vertex. But so at least we know that it's going to go to the right 3. We're basically just thinking of the vertex. So then this means that it's going to go up 6. Up 6. So that means it's right here. This is the vertex. 3, 6. Now we need to know... Oh, I forgot to say, there's one more thing. If a is positive, then it's going to be like this. And if a is negative, then it's going to be an upside down U, like this. So, is a negative or positive? A is positive. So that means that it's going to go like this, but we don't know exactly. We're not doing... This isn't to scale. We would actually need to graph this correctly. We would need to know the y-intercept, but there wouldn't be any x-intercepts in this case, because it doesn't touch the x-axis. So, is a going to be, is it in between 0 and 1, or is it less than 0 and greater than 1? It's greater than 1, so that means it's going to be more put together. So it would be something along the lines like this. So that's basically how you use transformations to know how a graph would look in vertex form. So that'll be it for this video. Thanks for watching, and I'll see you on the next one.